Good day to everyone on the West Coast. Good evening for everyone in Europe, and good midday on the East Coast. My name is Olivier Oullier. I'm a professor of behavioral and brain sciences and entrepreneur. And it is my pleasure today to be the moderator of a conversation between Gabriel Rene, who's the CEO of VRSSSF, and Professor Karl Friston, the chief scientist at VRSSSF. Gentlemen, welcome.
Thank you, Olivier. Good to see you again since we were all together at Davos. Appreciate you.
Yes, we were in Davos a few weeks ago, where VRSSSF made a lot of waves on stage, off stage, in conversations that range from purely business conversation to high-level scientific conversations, because Davos was also a place where people are not only interested in the business aspect of things, but investors, industry leaders, government leaders are really interested in the high-quality, high-level science that is behind or at the core of this AI trend that we hear a lot about, maybe too much. And one of the reasons I'm here today is because I spend a lot of time with you two, separately and together, bombarding you with questions, because I am a science geek above everything else. And I thought it was good to be able to share the advances that VRSSSF have achieved, Team VRSSSF, over the past months, that we heard a lot in the media, but it's always good, with all due respect, to hear it from the horse's mouth. This said, in December and January, you released various benchmarks comparing performance of agents powered by Genius, which is your trademark solution, that are playing Atari Pong and the code-breaking game, which is a framework of reference in computer science, the Mastermind. And you compared and you benchmarked against leading LLMs. And I think that before we delve into the conversation, I would love to share a very short video that would illustrate and guide us through this conversation, if you don't mind.
Thank you. So what you're seeing here is the code-breaking game Mastermind. On the left, you've got OpenAI's reasoning model O1 and the Chinese model R1 from DeepSeek. On the right, you'll see that Genius actually solves this code-breaking game, which is a multi-step reasoning that we need for agents, so quickly that you get into the hundreds of solutions by the time OpenAI gets to just a handful, and I think it stops when R1 gets one. And so what we're demonstrating here is a couple of things. You've got the top models from both the West and the East, the leading large language models that are being pitched as being reasoners, that they can think through multi-step reasoning. What does that mean? In the game of Mastermind, you have to try to pick this code, little code that's set up by the player. And then at each guess, where you try to pick the color and where the position of each of those little pigs are, you get a bit of feedback. Oh, you got one of the colors right and one of the positions right, but that's all I'm going to tell you. In each case, you have to reason through step by step using active inference, which is very much designed to do that kind of multi-step reasoning and adjust itself as it goes. You see that Genius is able to solve that very quickly. And the test with O1 as an example against OpenAI, out of 100 games, we solved 100, all 100, averages about 3 seconds. I think they solved about 71 out of 100. We were 140 times faster and over 5,000 times cheaper, in part because these reasoning models, particularly OpenAI's O1, requires the model to think over and over and over again. It's sort of asking itself 20 questions to see if it can get that. That's obviously more expensive. So what you're seeing is this demonstration of something we've been telegraphing for more than a year, which is that if you build domain-specific models that become like geniuses, experts at a particular task or a particular skill set in a particular domain, in this case, code breaking, it will outcompete the top models in the world using a fraction of the data in a fraction of the speed, and most importantly,
and fraction of a compute power.
And a fraction of the compute power. And this is, I think, the reasons underneath that are because our work is based on Karl's work. So perhaps Karl can comment on that. This also underwrites some of the functionality we talked about as we've been telegraphing around Atari, which we consider sort of the Olympics of AI benchmarks, which final results will be coming actually rather shortly here. So I think that's
the one
they use their Mastermind. We've been able to show that we could beat the top models with a fraction of the data, a fraction of the compute, and a fraction of the time, and with increased reliability, which, as you can even see in the latest Wall Street Journal article from just yesterday, the top CIOs all gathered, Wall Street Journal in Silicon Valley, and said, where are you adopting agents? Everyone's playing with them, but they said number one problem is reliability. So getting 100 out of 100 and being able to solve those problems at scale much faster means that you've just got a better solution for many, many domain-specific problems.
Gabe, we're going to take a step back and give the context of his games. Karl, you're the most cited neuroscientist ever. Never thought you were such a gamer at the core, and that you were into video games. I think before we delve into the science behind it, why this benchmark is so important in the history of computer science, and why what Gabe explained is key for the future of generative artificial intelligence and how it's going to be deployed. Because we have the compute power, but we need to decrease compute power. We need to decrease the cost. And this is such a landmark that you guys have achieved.
Well, thank you. Yeah, I mean, in essence, we're trying to foreground a different way forward that is cheaper, faster, and better in some well-defined sense. And these landmarks have been, or benchmarks have been chosen to really showcase the 1,000 times improvement on a number of metrics that can be obtained if you just take a different approach to this, a smarter approach. So I like the way that you sort of introduced the Mastermind results, because I think that really does speak to a fundamental difference between active inference as artificial intelligence and the current machine learning kind of artificial intelligence. And I think the clues are in the names. So there's a fundamental difference between inference in active inference and learning in machine learning. So problems like thinking and planning that are attributes of agents are problems that are of the class of inference, inferring, thinking about things. Whereas if you've just got some machine learning tech, say a transformer architecture or a large language model, the best you can do is to learn to think or learn to infer. And that's a very slow, very inefficient way of implementing reasoning and inference. So that's the basic point which I bring to the table, that there's a much cheaper, a much more sustainable in many senses, both in terms of the thermodynamics and in terms of the maintenance of people who use this kind of technology. It's just much more sustainable.
Karl, since you're mentioning learning, which is key, one of the questions is whether Genius was trained specifically to solve this task or not.
Well, that's a really great question, because if you're a thinking machine, you don't need to be trained. You just need to be smart. So no,
It's important to mention.
Yeah, well, yes. And also, I guess you're sort of driving at another aspect of applying active inference to create smart agents, and that's the fact that there's a generative model under the hood. So the Mastermind demo was equipped with the kind of knowledge that you would need to reason about the problem at hand. So it was equipped with a generative model that underwrote the reasoning and the thinking and the planning and thinking through different counterfactual futures in terms of how I should sort of commit to this solution or that solution. So when you've got a generative model, you can generate consequence or content from cause, which means that it's inherently explainable. And this is the other big, if you like, limitation of current machine learning approaches based upon, say, backpropagation of errors and deep neural networks. You have explainability baked in, not just in terms of the computer scientist or the person using a software development kit, but for any user. They can go in and query not only what is being thought about, but also the degree of confidence that the little machine has, because part of
that's very important, this degree of confidence that we don't hear about it enough. And building on this point, degree of confidence of a machine, but also there is a degree of confidence that people need to build with the benchmarks. And there are many benchmarks that we see for various models, pitting them against each other. Gabe, why did you guys pick the Atari one specifically? Because this is not something that we've seen a lot, sadly, in my opinion, over the past 2 years when LLMs been compared to each other.
So, up until LLMs broke out, which was 2022, the main narrative around AI and benchmarks had moved from, over a period of a few decades, from chess, right, in 1996 to then Go. AI's beating Lee Sedol, the world champion at Go. That was the breakout sort of deep learning approach. After that, the industry said, well, we need to be able to show that we can play more than one game if we're trying to build something that is generally intelligent, kind of like an AGI test. And we need to move from static games to ones that are interactive. So interactivity is a prerequisite. Generalization across multiple games is a prerequisite. And then the industry played a little game over a period of a few years where there was a model called Agent 57 that Google DeepMind put out that learned, I think it was about 80 billion parameters. I can't remember, but this is something like perhaps maybe 11,000 years of human training to be able to get beyond human level performance across X number of games. The industry at large said, okay, this is not a very good test because we're just sort of inflating the data and the compute. And so obviously the system is going to be able to learn how to get it together if it gets an infinite number of tries. How do we learn like a human? So Atari 100K meant you only had 100,000 samples of the game, which is about 2 hours of training, not years or tens of thousands. And Efficient Zero, which was the Alpha Zero version, was trained on that. We've seen a handful of big breakouts. That was a really the sort of Olympics of AI tests up until language models broke out in 2022. And at that point, everyone wanted to look at sort of like text-based challenges, which were not interactive and were not very generalizable. And the third thing was, could you be efficient? So Atari 100K became the benchmark for interactivity, generalization, and efficiency. We said we believe we can, meet or exceed similar levels of performance, demonstrating that interactivity, demonstrating that generalizability, but also do it more efficiently. Meaning instead of a 100K, we could do it with 10K. So
I think that's the key. The key is a factor 10 when it comes to how faster, more efficient your solution is. And again, what I think is important to share is we got a lot of our audience that might be familiar with these benchmarks and what it means, but even the general public can understand the fact that when AI models that they don't understand the mechanics, if I may say, in an simplific way. When you explain that it requires less trials, less compute, less energy, and basically it means that you'll be able to have more chances to effectively scale it. And I think scalability is one big issue that is on everyone's mind when it comes to solutions like this. So the next point I would love to discuss with you guys is, in your opinion, Karl, what are the key issues that VRSSS can tackle that other AI models face and are still struggling with at the moment?
I think they can be summarized as the issues and the problems that you could solve if you had a truly authentic agent at hand, an artificial agent at hand. You'll notice in your discussion with Gabe in terms of why Atari and similar games were chosen as benchmarks. He used the word interactivity, and only agents can interact. So I think you just need to think about, well, what kind of artificial intelligence has true agency? And if you think about it deeply, then the answer is usually that agents plan. They have the capacity to roll out into the future and select among the best possible future, given their understanding of how the world works. So any problem that requires authentic agency and the kind of thinking and reasoning that is conditioned upon the choices that an agent could make or indeed could recommend to you is the kind of problem that would succumb to this style of active inference of the kind that sort of genius aspires to. There are lots of other perspectives on this. The efficiency perspective, the sustainability perspective, the ability to create specialists as opposed to generalists, I think is an important factor. Speaking now to a much more federated ecosystem of lots of smart agents doing what they do best in concert with each other. So those are the kind of problem spaces that are currently out of reach of, in terms of efficiency, out of reach of current machine learning applications.
Agents are kind of buzzwords at the beginning of 25. I think, we hear agent this, agent there. And what I like in our conversations when the three of us spend hours just going deep in the science and the business is that there is the science aspect and the rigorous science with you, Karl, and with Gabe's vision, business vision. From a science perspective, this mere notion of agency has been a philosophical debate for centuries. You've been able, with active inference, to take a stab at it, and this is almost an insult just to call it a stab, is to provide and to make huge leaps in forward understanding it. How, from a purely business perspective, for starters, Gabe, how agents powered by VRSSS, how are they going to change the business from a concrete point of view? Can you share some examples? And then we will continue with Karl telling us from these examples how you can make it even better than it is now.
Yeah, thank you. Can you guys hear me okay?
Yes, absolutely.
We have a little bit of a thunderstorm here. It gave me a little power surge. So I think the really important distinction here is that VRSSS is not building a foundation model. We're not building one single large model that everyone is supposed to fine tune down into specific use cases. And this is, again, I'm gonna reference this Wall Street Journal article that just came out yesterday, where the top CIOs in the world joined Wall Street Journal and were asked this question about agents. Who's playing with them? 60+% are all testing them. This is why we're seeing lots of revenue for large language model companies. But not profitability, by the way. At the same time, you've got the number one problem they mention is reliability. So the challenges that current AI suffer from is reliability, unexplainability, and they're wildly inefficient. It's because they're trying to take something really large and squeeze it down to focus on a very specific domain-specific problem and solve that. That lack of reliability, meaning that they hallucinate, that they're error-prone, that they're missing some key information that wasn't part of their training data, is the barrier to agents, because agents have to be reliable enough to be autonomous. That means we have to trust them enough to be able to perform a task. When Karl talks about agents learning cause and effect, this is very different from just learning correlation. And so whereas you can get really far with a language model or a vision model or a robotics model today, they can't solve the last mile problem of actually understanding a specific domain well enough to perform at expert level, or what we think of as genius level. And this is where Versus as a company is focused from a go-to-market strategy. It's not a wholesale drop-in replacement for every form of AI. It's to say that your language model has these issues and can't solve this domain-specific problem for you as a cybersecurity company, as a telecom trying to determine fraud, as a car manufacturer trying to avoid certain accidents in scenarios that are uncertain, and as a company building vision models. Like, my Ring camera thinks that a spider building a web in front of it is someone walking in my front yard at 3 a.m. And that's just not the case. So these hallucinations that occur across all these models, both in sort of digital and physical spaces, require agents that can learn to be domain experts, genius level within each of those domains. So a genius platform is designed to allow these individuals, organizations, and developers to develop these genius models that then fill the gaps and solve that last mile problem to ensure that they have reliability and can operate at the edge and in environments that where today current models struggle.
If you were to share with us the one sector where the agents that you build are going to be operational soon and make a difference in one business sector, what would it be?
I think that there are, you can tell by the beta partners that we have that there isn't one sector. As Karl says, if you build things that can think, that are actually smart, they're going to be useful for many sectors, in the same way a computer is useful for many sectors. But I do think that there are markets that are emerging where there is early traction. And we're seeing that in really two areas. Areas like fraud detection, and or areas that are then smart city related. So both areas that have to do with data sets that you have a rare occurrence. And just think about this for a moment. Autonomous cars are crashing. Okay, but they have problems crashing. The same thing happens in cybersecurity space. Fraud detection. These are not the most common patterns. They don't have the most amount of data. So having agents that can learn from small amounts of data, and also these are environments that are constantly changing. Fraud detection is, you're not dealing with the fraud of last year. This year's fraud is different. These are multi-billion-dollar markets that have these challenges. But in both cases, both the sort of physical one and the digital one, you're dealing with edge case, rare occurrence, constantly changing in data or environments. And Genius is really well suited for that, because today's solutions literally can't solve those problems. So we're seeing early traction in these areas.
Well, this is a great transition to for me to ask Karl. Again, Gabe mentioned the things that think. So the said things, Karl, they start to think, but how are you going to make them think better or smarter in the near future?
Yeah. So it's gracious of you to say that we've done more than a stab at things. I'd actually be more humble and say we've done some gentle poking at the nature of a long way to go yet, in the broader scheme of things. But to think is as an agent, I repeat, requires this capacity to imagine a future that you have some control over and select among those different futures. And your question, how can we equip people with partners, agents, artificial artifacts that have this in a useful way and do things better? To do things, I would take a biomimetic approach. What do you mean by better? And at the end of the day, you would fall upon evolutionary thinking, and you'd say this particular artifact has a greater adaptive fitness in this particular user system or ecosystem or network or whatever you want to describe this web. What is adaptive fitness? It's just the ability of this specialist, which is not the generalist of the monolithic large language models or foundation models, but this specialist has adapted to this set of inputs and outputs and interactions with her users or other artifacts. So you have to ask yourself then, how do you quantify and optimize adaptive fitness? And that's precisely what is effectively under the hood in terms of the Bayesian mechanics that underwrites active inference. It's a measure of how well I have adapted to my inputs and outputs and my interactions, my exchanges with my digital or physical world, scored in terms of the likelihood that my explanations for these and the way that I actively solicit these inputs and outputs provides the best explanation. If you had a thinking machine that could not just do this, but actually saw itself doing this, then I think you're now taking a baby step towards selfhood. And then I would imagine you would argue, if we have time, that would be a necessary precondition for knowing that you are a self and your true sentience or awareness. But I think there are lots of steps we have to take first before we get that far.
So, Karl, I have a question actually on that note. I think some investors have tuned in today to hear about the product roadmap, and you've stumbled them right up to self-conscious intelligent agents. But I think that also hints at the uniqueness of the underlying research here. We certainly hear similar narratives from some of the big AI companies, talking about that level of selfhood. But what they're sort of missing is agency itself. And you mentioned something earlier, which I want to make sure everyone understands. Today's AI models are essentially just a representation of the data they've been trained on. And you ping it like it's a database, right? And it basically provides you an answer. What Versus is doing with Genius is more like building a processor, like a CPU that actually is running in real time and processing information as it goes. It's learning and adapting, as you pointed out, in real time and by itself. And so, in effect, that ability to then have a model of the world, which then it runs predictions on, then uses those predictions to try to determine the right answers and the right actions to take, is a very different architectural paradigm. But it also explains why we're able to get more reliable results. We have models that become experts at what they learn on. Number two, they're wildly efficient when they do this because they're not trying to learn everything. And number three, they can adapt. And so this idea of reliability, higher reliability, greater efficiency, and because they're predicting in such a way that we can see those predictions, you end up with explainability. And these are the three major gaps, the last mile problems in the AI space that I think active inference based approaches, which Genius, is leading, and Versus is leading, has really been the key. I don't know if Olivier is dealing with the same storm as me, given that he's in France and I'm in Los Angeles, but looks like he's dropped for a minute. So why don't I ask you a final wrap-up question, Karl, which is that there's all kinds of research work being done out there in the active inference space. There's all kinds of companies, large corporations building AI. Why have you decided to work with Versus, and what's the driver, of being the chief scientist for you inside of Versus?
I think it's versus commitment, which you and I know is, probably goes back several years, if not half a decade, to doing things in the right way, in a principled way. And usually that transpires to be in a way that not only is based upon the physics of self-organization from the physical sciences, but also has a lot of biomimetic commitments that complies with the principles of self-organization in amongst ourselves, ethologically speaking, and also in terms of self-organization. So that commitment to getting the principles right and applying them for the common good that is realized commercially is, I think, unique to Verses, certainly in terms of resourcing the intellectual infrastructure that sort of allows us to try and provide proof of principle that is of commercial utility. So this is a gift from the point of view, my point of view as an academic. It provides the acid test. Have you got the right principles? And of course, we clearly believe we have. But we'll only be able to demonstrate that to ourselves, I think, when there is a general uptake and proof of principle out there that by the very use provides its own existence proof. And Verses is to my mind, the kind of vehicle that you would use to seek out that existence proof.
Thank you. Olivier, we lost you for a moment, but I was just talking a bit with Karl about why he decided to join Verses and what is it about, Verses' mission that, as you said, drives the commitment to that. And I just for your own knowledge, the answer is effectively, he believes that we're the leader in the space that are both in the sort of AI world compared to the large companies, which you could certainly get their attention.
Well, I can speak as a neuroscientist who's been trained reading Karl Friston, using solutions, open source solution that Karl and his team put together. It's true that from the neuroscientist point of view, seeing that you guys managed to sign Karl Friston is a bit like Real Madrid signing Ronaldo. I mean, for me, I'm not sure our friends in the US sign, or we'll say Tom Brady being signed in Florida. For me, what is important also is the fact that within Verses, there is, of course, your commercial venture and their products. But Karl, I think it would be interesting for our audience to understand the balance between research that is oriented towards developing products versus fundamental research that is core to whether we would talk to people at DeepMind, at Meta, they all insist on the importance of saving this haven of fundamental research that might not be goal-oriented from the get-go, but always end up contributing to the products, one way or another.
I think that sort of commitment you'll find in any successful company. And the last time we spoke about this, I was sort of trying to slip in Google DeepMind were exactly this. When they started, they were exactly a bunch of people up front who were doing automated, what would I look like in this dress to make the money? And then a bunch of Dennis and his friends in the back room building models of the hippocampus. So there's always been this duality, and I think that's been manifest and realized in a really admirable way by Verses, who explicitly created a little tiny university inside a company. So there's this dialogue that goes on. So every level and every scale in terms of a commitment to the fundamental academic research, right through to the finesse of product is all it's all, if you like, within the same infrastructure, and as such we can contextualize some of the academic work, and of course the product orientated parts of the company can lift up and use the most recent advances to great effect in terms of showing them to people, look, this is what you can do if you commit to this way of doing it.
Olivier, I just want to add one comment here, which is that I think this is somewhat unique for a startup. So big tech companies like Google, can bring in a deep mind, and that was one little corner of basically a search engine company. And now it's become the front and center, for them after investing billions of dollars into that research. We don't have billions of dollars to invest in research. We also needed to pick just the right thing. So when Karl and I first, met and started talking many years ago, it's been upwards of 4 or 5 years now. When we talked about the opportunity to potentially work together in the future, which was formalized just a couple of years ago, it was around this idea: can we pick the best of the best in research, hand selected by Karl, and combine those with the right kind of productization and commercialization teams? And so today you've got, really great active inference research teams that are kind of researching the far distant future of active inference. And you've got amazing big tech AI companies that are at the front edge of productizing, AI products. We're coming right through the middle of that, applying the best research, coming out of neuroscience, not just computer science like the big ones, but with the product and commercial teams and skill sets that the active inference research teams, frankly lack. That I think puts us in a pole position that really gives us the leading edge with being able to bring these technologies to the market.
One thing that is very important is in general, but we heard a lot this week because I was at the AI Action Summit in Paris. I'm now in Cannes, France for the World AI Conference, is the safeguards, the guardrails when it comes to reasoning and what the models do. And I think it would be great to hear you call on what Versys has put together, so to say, in order to make sure that when the inference happens, when the decision-making happens, there is a way first to quality check the reference and the decision, but also to make sure that the learning is reinforced with the right things. And by the right thing is what is legal, but what is ethical, etc.
Yeah, that's a brilliant question. So I think there are answers at two levels. The first one comes back to what we were talking about before, that there is an explicit representation of confidence or uncertainty, technically uncertainty quantification in this kind of intelligence or active inference, which means that gets into the mix when reporting or making recommendations. So you don't just have a decision that may or may not be emitted with a certain degree of conviction. You actually get confidence intervals or Bayesian credible intervals about that. So you know how confident this recommendation is, or the confidence with which it is made. The other, I think, really important issue is, how do you define, how do you regulate, how do you ensure alignment? And basically what you're saying, I think, is that, how can we operationalize the definition of what we think is acceptable and is better? So you'll be coming back to the fundamental objective function. I think when you're talking about constraints and guardrails and these notions, you are basically stating that the constraints that underwrite the objective function are multidimensional in nature. So we've got a multiple constraint satisfaction problem that is exactly the kind of optimization problem that active inference deals with, because it does not rely upon a single monolithic reward function. So the only reward function in play is its adaptive fitness, where the adaptive fitness is just written down in terms of this generative model, which is the way that it should behave and the way that it should not behave. And when it transgresses those kinds of behavior, you literally get an increase in free energy and there's a retraction. So you keep it within the bounds that are specified by the user, but more generally by everything that interacts with any of these agents. It keeps within those bounds in the spirit of multiple constraint satisfaction.
Gabe,
let me translate
from a commercial standpoint. No, but yeah, that was the ball I wanted to throw. It's
classic Karl Friston. Let me try to distill it. Go ahead, Olivier.
No, just wanted to ask you, what does this mean in terms of business? Because this is also important to make sure that you got the right science and the right tech behind in order to have these guardrails at play. But also, this is something very, very important. I'm sure your clients, your partners are concerned about the effort that you put into making sure that you got what is called safe AI, responsible AI, depending on the conversations.
Yeah. Okay. So a couple things. One, I think, looking at the summit, the AI summit in Paris just this last week, we saw a major shift away from safety, and in part because the U.S. and others are kind of suggesting that too many guardrails will inhibit innovation.
Sure. Vice President Vance made it very clear in his speech.
Yes, and so you've got a shift now in the global ideas around AI governance. I just want to take that backdrop and connect it out from what Karl said to the to industry. The problem with today's AI is this conviction. He said they say the wrong thing or do the wrong thing with 100% certainty, but it's that lack of grounding, that lack of reliability, that lack of true understanding of the recommendations or actions or outputs that they're providing. That is the main safety problem, right? And so the way that that's addressed here is what Karl said. By having agents that output confidence scores that we can see that they are more confident or less confident in one potential decision or action or output than the other. This allows us the ability to steer. This allows also, because of the adaptive nature of these models, to say, I think it could be option one, could be option two, option three. Oh, three worked. That's better for you. Now you and I are more in alignment. Or if you take it regionally, the outputs or values that the Middle East might have, say Saudi Arabia, might be different than those in Paris, which might be different than those in Florida. And you need to have agents that aren't just trained on monolithic data sets that only have those sort of ideas about safety or values or value, right? And so from a commercial perspective, we believe that having domain-specific models that are able to output those confidence scores, that are able to adapt to changing circumstances, environments, conditions, and regions is actually a huge advantage that is frankly just a limitation. And so when you hear about beta partners signing up for Versus, the first thing that I want you to think about is, if these folks had a solution to their problem, they would not be announcing a partnership with us. It means that we're solving a set of problems around this issue that are inherent to the limitations of the best performing models in the world. And tests like Mastermind and Atari are just indicative of that capability, which, to Karl's point, because we've set up the correct way as an organization, and I think uniquely for our kind of an organization, by being able to take this bleeding edge science and research, which can be demonstrated in benchmarks, and rolling that right into product that then comes out and has that kind of real world impact, addressing that gap that highly convicted but wrong models have in the world, and solving that last mile problem by ensuring that reliability is baked in as a native feature of Genius.
One thing that the market reminded us very recently is the importance to have a product that specialists and non-specialists adopt and understand. One of the reasons there was such a tsunami with DeepSeek a few weeks back is because there was an app that everyone could use. And how important was the strategic decision that you made, Gabe, as a CEO, to have Genius as a product in the growth of a company and in earning new partnerships and clients?
Well, I mean, two things. One worth noting is DeepSeek came out. We were all at Davos together, and it kind of rocked the whole the whole AI world. You had Trump come out, golden age of America. You've got the tech CEOs sitting in the front line. AI pedal to the metal. $500 billion for Stargate, because obviously everyone thinks you need to build, the largest possible model. And then the next day, within 24 hours, DeepSeek comes out and says, oh, we've built this for a fraction of the cost. I think the major gap there is it didn't get much better. And so the reliability issue is like, it doesn't really matter if these models get to so-called 90%, 95, 96, 97, whatever those last percentage points are, that's the liability risk that they just struggle to solve. And it's why on one side of the fence, they think they need, actually, Sam Altman yesterday said 500 billion just to start, we need 5 trillion. So we think that they're barking up the wrong tree. And even though they will continue to improve these models, they're not going to solve that last mile part of it, which I think Genius is ideally suited for. So from a product development and commercialization perspective, that is the perfect entry point. Now, what you need in order to hit that target is a market that's ready for it. And the AI world is 2 years old. In the last 90 days, the whole world and all the industries have shifted very heavily towards the agent-centric narrative. We predicted this over a year ago, and we've been building towards this. So it's hard to be patient. It's hard to, as Karl says, commit to first principles and get the underlying science right. But we believe that the long tail benefit of that, even in the near term here, is going to be demonstrations that are commercially valuable and viable in the market with our Genius release, which is coming out in Q2 here, the commercial version of the product, that's going to start to build that wave that's going to drive most of the enterprise in Fortune 500 to have to use us in order to solve the problems they want to solve that they cannot solve reliably today. And if that isn't a market opportunity for a startup, I've never seen.
Well, I can, first, full disclosure, I am in no way related to Versus, except that I like the science and I like the technology. But I just wanted to say that I can testify that you indeed mentioned this more than a year ago. I remember interviewing you in Davos 2024 and moderating the now legendary intellectual battle on stage between Karl and Yann LeCun from Meta, where this was also addressed. And it's one way to have a vision, but it's another to be able to deliver on that vision in the right time frame. And how confident are you, both from a business perspective first, Gabe, and then scientific perspective, Karl, that you can keep up accelerating the R&D, given that now it's no longer a race, it's a mega sprint that we're in the middle of when it comes to innovation, the products, and deployment of AI.
Maybe I'll lead in that part of Karl's answer as well. I think, look, there's 395 people on this call. Almost every major tech company's quarterly report has an exponentially larger number, and everyone in the world is paying attention to these big companies and the moves that they're making. Thank you all to 397, a couple pop back in, that joined today that are paying attention, because this is the tiny little sound that's happening in the corner that's largely been ignored because all of the oxygen's been sucked out by LLMs. This is a huge advantage for all of us because from a patent perspective, from a product development perspective, from the underlying science perspective, we have the pole position. And I'll just give it a commercial example so we can all remember. Tesla decided to build a car from a battery, and not BMW and not Porsche and not Toyota and not Ford, right? And even though they were doing hybrid stuff at the time, nobody even had the skill set in those companies to develop a battery first, complete different paradigm shift to cars, right? And that the rest of them are invested heavily in trying to optimize their combustion engine by doing fuel injection, what they call now reinforcement learning. And these optimizations are cost hundreds of billions or trillions of dollars. We think there's a better, faster, more efficient way to do this. We've already demonstrated that against the DeepSeeks and the O1s of the world. We're quite confident that we have our position on the field, which is not merely just to replace what they're doing, but is a big enough position as a small company to be able to, I think, really lead the gaps in the AI space. So we are extremely confident because we have cornered the market on being able to take active inference from research to product. And that means you need the right science, you need the right leadership, you need the right technical teams, And you have to develop that organically internally. You can't go buy that somewhere, and you can't just grow that out of an academic sort of culture. And that was really the benefit of what I think when Karl and I first started talking, we spent quite a few years just getting to know each other to build that kind of trust. Can Karl bring the science and the research? Yes. Can we bring the right commercialization opportunities and develop the technology into a product? Yes. And today, now you're seeing the fruits of that labor. And I believe 2025 is going to be the year where everybody sees that.
Karl, Gabe has answered part of what I know you could have shared. So let me change a little bit the question for you. Moving forward, as a scientist who is now working in the industry, what is, if you had, I don't know, magic wand, what do you need in order to make the science even better that you don't have yet and that you guys are working on that you can share with us?
I'm trying to work out whether doing a classic Friston is a good or a bad thing. So,
please do not do a classic Friston. This is not a science geek question.
Okay, fine. I think I don't give you a banal answer, but I think it's one that you like. I mean, both you and I have grown up in an era where understanding ourselves in terms of neuroscience has been a real thing, with enormous advances in terms of brain imaging, optogenetics. There have been real paradigm shifts in activism at the turn of the century. The things that make these work, that also speak to the confidence and the timeline of penetration commercially or into the markets of active inference, the things that make this work is when there's a socialization of the tools to answer people's questions and solve people's problems. And, if we were having another conversation, this would be the importance of open science, but particularly the open science that democratizes software analytic tools that allow, I repeat, people to answer their own questions and implicitly solve their own problems. So if I had a wand, it would be basically that we could democratize active inference of the kind embedded in Genius, and that would be an uptake, and in that uptake and adoption, there would be a communal feedback so that we can now further disseminate and socialize this kind of approach. So that, it's basically exposure, but one has to be patient. I mean, you remember, through the 90s and, with every wave of different image analysis software, you got to do the groundwork about, usually takes about 5 years, and then you have to be patient for about 2 or 3 years until you move from this is rubbish to, that's obviously the way to do it. Great, and I think we're sort of, on that point of inflection now. But if I had the wand, I'd like to get to the crest of the hill and just have a little rest.
What I like is Karl advocating for patience, knowing that neither you, Gabe, I, and anyone who's in that race at the moment is patient. We're super impatient, but I would say, if I may slightly correct, I would say we got to be wise in that race and deal with our impatience. But of course, I would agree. And I think, it's time to end. And I think it's a good end to talk about patience, impatience, and doing our best to be wise with the powerful technology. Gentlemen, as usual, it's a pleasure to have a conversation with you. As usual, it's way too short, but I'm glad that for once I'm able to share it with hundreds of people. A little plug here for the upcoming videos of conversations between you, Gabe, and Thomas Crampton. You, Karl, with me on stage at Davos, and another one with Travis Oliphant that we're going to share in the coming weeks. Please look for the Centaur's AI to hear more about what VRSSSF is doing. There are not so many overlaps between these conversations in Davos and the one now, so it's a good complementary pair, as our dear friend Scott Kelso would say. Karl, thank you so much to everyone, to the hundreds that logged in, and as a science geek, I'm looking forward to hearing more about you guys do and how you compete with others. Until the next time, gentlemen, thank you, everybody.
Thank you, Olivier.